In this video, we'll understand the concept of ratio and proportion. Now, when two quantities are compared, for example, A upon B, this is called the ratio. And when the two ratios are compared, that is called the proportion. Now, ratio is not in our syllabus, so we will focus majorly on the proportion part. So, if A, B, C, D, if these four quantities or four numbers or four values and none of them is zero are having a similar ratio, then we can say A, B, C, D are in proportion, which means A by B is equal to C by D. So this D is called the fourth proportional. So in exam, maybe 1 markers or MCQ type questions, you can be asked if 15, 25, 30 and D are in proportion, find the value of fourth proportional. So using this formula, you can directly put the value and find the value of the fourth proportional. Similarly, we have one more thing called continued proportion. So this is our normal proportion. In continued proportion, we just have three quantities, and this middle quantity is the relation between both of them. So it will be A by B is equal to B by C. Here the C is called the third proportional and B is called mean proportional. So again, in 1 markers, you can be asked a question, you'll be given some values. Out of 3, you'll be given 2 values and you'll be asked to say find the mean proportional or find the third proportional. So using this formula, you can directly go for, finding the values which are missing. In this case, you can only find the fourth proportional. In case of continued proportion, you can find the mean proportional as well as the third proportional. Now, let us take a question to understand this concept better. So here we have if x plus y is the mean proportional between x plus 2 and x plus 9, find the value of x. So as I just explained, in mean proportional A by B is equal to B by C. So we can say B square is equal to AC. This B square is equal to AC. So for us, x plus 5 is equal to B, x plus 2 is A and x plus 9 is C. So we'll simply put the values here. So x plus 5 the whole square is equal to x plus 2 into x plus 9. We'll open this bracket and we'll multiply these two brackets. So this becomes x square plus 25 plus 10x. Remember, you are supposed to use a square plus b square plus 2ab. This is equal to x square plus 2x plus 9x plus 18. X square you can strike off. So 18 comes on this side, 25 minus 18 is equal to 11x minus 10x. So x is equal to 7. This is how you can solve more questions based on the mean proportional, continued proportion, normal proportion, third proportional and the fourth proportional. Now let us take a very probable and very important type of question, which is a prove that question based on the proportions. So the question is, if A, B and C are in continued proportion, prove that A square plus AB plus B square upon B square plus BC plus C square is equal to A upon C. So we actually have two ways of doing this question. One is a short method, that if in exam you're in a hurry or you can't think much about the question, there's a short method which works for all kind of questions which are a prove that ones. So what we do is, here we take A by B is equal to B by C. So this is our continued proportion. So A by B will be equal to B by C. We assume this to be equal to K. So this implies, if I take this part, I can say B is equal to CK and A is equal to BK. But we have already established a relation here that B is equal to CK. So I can say this is CK into K. So A is equal to CK square. So because of this, B is equal to CK, and when we take this part, A we get as CK square. So we simply now use the LHS and we just put the values. So the LHS is, yeah, one more thing. Whenever you have proved that questions, don't take LHS and RHS together. Solve any one side individually. So LHS is equal to A square plus AB plus B square upon B square plus BC plus C square. We simply just put the values here. So A is CK square. So it is CK square the whole square plus A is CK square, B is CK plus CK the whole square whole upon B square again will be what? CK the whole square plus BC, that is CK into C plus C square as it is. We just simply solve it again. So this becomes C square K power 4 plus, now this is CK square into CK, so it becomes C square K cube plus C square K square whole upon C square K square plus C square K plus C square. So from here in numerator, we can take C square K square common. So we are left with, now because we have taken C square K square common, we are left with K square in the first term, K in the second term and 1 in the last term upon. From here also we can take C square common. So we get K square plus K plus 1. We can strike off this entire thing. C square gets cancelled. So we are left with K square. So my LHS is K square. Now let's take the RHS and solve it. So RHS is A upon C. Now A we have already established a relation at CK square. So CK square upon we have C. CC gets cancelled, so it is K square. So we see here LHS and RHS, we have proved both of them as equal to K square. So we can say hence proof. This part is proved. Now in case it clicks you in the exam to use a shortcut, there is a shortcut as well. So we just take here, we just write it here or. So we take the LHS again, that is A square plus AB plus B square upon B square plus BC plus C square. So what I will do here is, wherever I have B square, I will just put the value as, now if I establish a relation here, so I can say B square is equal to AC. So I will just use this value of B square in your numerator as well as denominator. This will be equal to A square plus AB plus B square. So instead of B square, I will use AC upon AC plus BC plus C square. From the numerator, I see A square here, A here, A here. So I can take A common. I am left with A plus B plus C whole upon. From denominator, I can take C common. So I am left with A plus B plus C. We can strike off both of them. So we get A by C, which is equal to RHS. Now this is a very shortcut method. Of course, you can apply in the exam provided it clicks you. If it doesn't, this K method will sure shot apply for all the proof that questions that come in the proportion question. Now let us take a very important part of this chapter, that is the properties of proportion. Now these properties of proportion are very important with the board exam perspective. So let's take them one by one. The first is when A by B is equal to C by D. So this is our normal proportion, right? So first property is invertendo. So when I say invertendo, it means I am flipping both these sides. Now always remember very carefully, whenever you apply any property of proportion, you have to apply to both the sides. Kids usually make a mistake and apply only one side only, but you have to remember that you have to apply this properties of proportion on both the sides. So when I say invertendo, we have to flip both of them. So it will be B by A is equal to D by C. Second property is alternando. Alternando. So when I say alternando, it means we will alternate the positions like this. So this becomes A by C is equal to B by D. You can do for this also, A or D, but either of them. So A by C is equal to B by D is your alternando. Third is componendo. So we have this A by B equal to C by D as our normal proportion. We add 1 on both sides, so it becomes A plus B upon B is equal to C plus D upon D. So A plus B upon B is equal to C plus D upon D is your componendo. Fourth is dividendo. So the way we did plus 1 here, this time we will do minus 1 again on the both sides. So this becomes A minus B upon B is equal to C minus D upon D. So this part where we are doing subtraction is called dividendo. And the fifth one, which is most widely used in your questions, will be componendo and dividendo, which means we use both of them together. So what we do is we will divide both of them, so it becomes A plus B upon B whole upon B, A minus B upon whole upon B. This is equal to C plus D upon D whole upon C minus D upon D. So we can just strike it off. So final answer is A plus B upon A minus B is equal to C plus D upon C minus D. So if I am given a proportion like this, A by B is equal to C by D, and we are supposed to apply componendo and dividend together, so it will become A plus B upon A minus B is equal to C plus D upon C minus D. Now, let's take a question based on this concept. If x square plus y square upon x square minus y square is equal to 17 upon 8, find the value of x upon y and x cube plus y cube upon x cube minus y cube. So let's take it one by one. So it is x square plus y square upon x square minus y square is equal to 17 upon 8. We are supposed to find the value of x by y. So what we'll do is we'll first apply componendo and dividendo. So by componendo and dividendo we get x square plus y square plus x square minus y square whole upon x square plus y square. Now in here we have to subtract it, so it will be minus x square plus y square, because the sign of minus will change now because it is we are subtracting it, so it will become plus y square. Remember, in proportion the property has to be applied on both the sides, so this will also become 17 plus 8 upon 17 minus 8. So let's solve it then. So y square I can cancel, x square I can cancel. This will become 2x square upon 2y square is equal to 25 upon 9. So we can just cancel this 2 also. So we are left with x square by y square is equal to 25 by 9. So we will take the square roots now. So when we take the square root, x by y will be equal to plus or minus 5 by 3. Because it is the whole square, this plus and minus is required. So it will be plus or minus 5 by 3. That is the value of x upon y. Now we are supposed to find the value of x cube plus y cube upon x cube minus y cube. So we'll simply take it here. X by y is equal to 5 by 3. Right now I am considering the positive case only, but in the end you can always apply plus or minus, because if we take the plus, we will have the plus answer. When we take minus, we will have the minus answer. Now because we need cubes here, we will cube both sides. So this will become x cube by y cube is equal to 5 cube, which is 125, upon 3 cube, that is 27. Now because we want plus in numerator and minus in denominator, we will apply componendo and dividendo both. So by componendo and dividendo, we get x cube plus y cube upon x cube minus y cube. Now again we will apply on both sides, so it will be 125 plus 27 upon 125 minus 27. When we add them, we get 152 upon 98. Because this is the ratio, it has to be in the simplest form. So we can strike it off by 2, making it 49, and this is 76. So 76 upon 49 is my answer. In the similar way, you can solve more questions from your textbooks and the reference books.